to configurator. Okay, my friends. Hello, all over the world. Hello, other parts of the world. Happy Saturday. Oh, I'm wearing yellow. Dilawan. O, diba? Okay, guys. Dilawan, diba? Oh, diba? Yellow. Okay, so we're gonna have, shall we say, this is another topic but connected to the previous topics. Okay, like this. This is gonna be covalent molecular compound. So as you can know this class, the topics are really interconnected with each other, right? We can connect the past, the present, somewhere along the way like that, but we need to focus on the present topics this time. Okay? Covalent molecular compounds. Okay? Oh my gosh.
The Bluetooth device is ready to
Wait for a
pair.
while. Mapalangga. Okay. So I have, wait mga palangga. Hitad. Okay. Hitad talaga. Okay. Chop. So, do you hear my voice now? I need to off the phone. Okay. So that's really my hands like that. Okay. So, covalent molecular compounds. Oh, diba? So, now investigate the terms before going further. We have the covalent. Okay. We have the molecular. And we have the compound. Something like that. Okay. Covalent. What do you mean by covalent? Covalent is driven by chemical bonding, okay? Chemical bonding through the transfer or sharing of electrons. So this is technically what we refer as covalent, okay? The transfer and sharing of electrons, okay? Driven through chemical bonding, okay? So there are two types of covalent bonding, okay? The polar covalent band and the non-polar covalent bonding, okay? Do I have to write or you will just listen and take down notes, okay, in a blank sheet of paper? Because please understand, I have a very, very limited space in my whiteboard. I cannot write everything. Okay, as you can clearly notice all the time in my vlogs, I cannot write everything, right? Okay, so just take it down or simply register automatically in your brain cells. Anyhow, no, the statements, the words like that are not very lengthy. It's easy to, it's easy to retain in our brain cells. It's easy to memorize, something like that, okay? Or if you want really, then put that in a blank sheet of paper, okay? So that is we refer of covalent. Again, covalent means there's a sharing and transfer of electrons. Okay, so we have two types of covalent through driven by chemical bonding. We have the polar covalent bond and a non-polar covalent bond. Okay, take notes. So I have to write na talaga, di ba? Okay, two types. Okay, the polar covalent bond. Okay, and the non-polar covalent bond. Okay, non-polar covalent bond. As you can notice also, this type of bonds are very popular in examinations or let us say facing any competition regarding chemistry. Okay, for example, science fair, chemistry quiz bowls like that. So you can always notice this kind of questions because these are very basic in chemistry. Okay, general chemistry lecture 1. Okay, polar covalent bond meaning to say that there is an unequal sharing of electrons. Okay, an equal, okay, sharing of electrons. Okay. So basically, the electrons had been transferred, but it just happens that there are remaining electrons that are not shared. or meaning to say lone pairs or unpaired electrons. If you see molecular compounds like that, then that is really a polar covalent bond. Okay, so there's a lot for this examples. For example, we have the water. Okay, the water. We have also the, for example, the what else? C2H6, ethane, like that. Most of them are hydrocarbon compounds. Okay, why? Because most of the hydrocarbons are non-metal to non-metal. Okay, as you can observe, guys, it's a wrong concept that a carbon atom is a metal. That is non-metal really. Okay, non-metal. Carbon atom is a non-metal. If you bond carbon and hydrogen, chemically combine with each other, okay, that's gonna be a covalent molecular compound. Okay, so H2O, why? There's an unequal sharing of electrons. I will show you how. Okay, so for example, in this H2O, we need to determine the backbone atom for the chemical bonding. Okay, if we can review our chemistry, like we need to start octet rule. Okay, you know the octet rule? So at least there are maximum of 8 electrons during chemical bonding, and it will never exceed for that. That's the rule. Okay. For example, oxygen. If you can remember oxygen, this belongs to the group 6A family. Sorry for my tongue. Okay? Group 6A family. So it's going to be 6A family. G6A family. And hydrogen is G1A family. Group 1A. Okay? Hydrogen, group 1A family, meaning alkali. Okay? Alkali. Though hydrogen is a gas, okay, the lightest element in the planet Earth, discovered by Mr. Henry Cavendish. Okay, but it belongs to the grouping of the alkali, but it will not behave as an alkali. You get the point? It is just found in group 1A, in the alkali group, okay? But it will not act as an alkali. Okay, so very special, this hydrogen. If you will see and take a look of the periodic table. Okay, now if that's the case, we have only one electron in the outermost shell of hydrogen. So just put one dot for hydrogen, right? One dot, like this. Okay, one dot for hydrogen, ganon. And then oxygen belongs to the group 6A. Okay, so there are 6 electrons in the outermost shell. Okay, now here you have 2 hydrogen atoms because of the subscript 2. Put another H here with 1 electron also, like that. Now we have the oxygen as our backbone of our chemical bonding using the Lewis dot structures. So we will put the oxygen in the center of the 2 hydrogen atoms. For example, like this, oxygen in the center. And the oxygen have 6, right? So 1, 2, 3, 4, 5, 6. So 6 electrons or valence electrons in the outermost shell. Ganon. Okay. Now, you try to connect the electron and the electron of oxygen when they shared electrons over the other. Okay, connect with a straight line. Okay, like this. Okay, it's now H2O. So there are remaining unpaired electrons. How many, mga palangga? 4. 1, 2, 3, 4. Okay. There are 4 electrons remaining unshared and unpaired, something like so 4 electrons. Okay, now this will satisfy your polar covalent bond because the definition says an equal sharing of electrons. Due to the unequal sharing of electrons, we have electrons not being shared. Okay, get the point? Now this will become H2O. Now, due to the arrangement of this type of bonding, it will bend. Why it will bend? Just like this. Because the oxygen having more electrons. So it's heavy compared to hydrogen. So the hydrogen will bend. So it will be going like this. Okay, tadadat, ganon. This is the actual formation or structural formula of water. Okay, it's gonna be like that. It's no longer straight anymore on the horizontal plane, the hydrogen atoms. Okay, so that's gonna be like this. Okay, now this is an equal sharing of electrons, polar covalent bond. Okay, ganon. Get the point mga palangga. Okay, so this, sorry for my voice. For this, for unpaired electrons mga palangga, this also causes the water to be highly conductive to electricity because these are unstable electrons that need to activate or to react with another electrons that will flow, for example, in a path or a wire, something like live wire. Okay, that's why electrocution comes in. Okay, because of the situation technically, because water is a polar covalent molecule. So these four electrons will try to react to the electrons also that will flow in the wire. Then if you step for the water, then electrocution comes in and you will be there will be a grounding. And eventually like that. Okay, that's the main reason. It's a technical reason why there's an electrocution. Due to the water is a polar covalent have exist electrons. Because if it has no exist electrons, then there will be no electrocution because the electrons are stable. But in case of water, the electrons are not stable. Get the point? There still exists 1, 2, 3, 4. Okay? So that's why you need to put away the water from the live wires. That's the main reason. Okay? Okay? That is the main reason why electrocution will be happening, grounding will be happening, something like that. Aside from another physical obvious reasons, but this is really the root cause why electrocution comes in. Due to the water itself, the property of the water itself. It is polar covalent bond. Okay? Something like that. So basically we can say water is a polar, okay, covalent molecular component. Perfect, right? But usually it is known only as a covalent molecular compound. Dropping the polar is just okay also. Okay? As long as we understand that water exhibits polarity. Okay? Something like because it has a lot of polar molecules. Okay? Something like that. Get the point mga palangga? Now, we need to give you an example of a non-polar covalent bond also. Okay, this is now the sharing of equal electrons. Still transfer of electrons, but equal sharing of electrons. So, we go to the most and basic example, guys, so that we can understand. So, the rest will just follow, the pattern will just follow the principle, okay? Okay, of electrons. So we're gonna start with the most basic hydrocarbon. Okay, this will be the starting point of the hydrocarbon compound. All hydrocarbon compounds, guys, are molecular compounds, technically covalent molecular compounds, because of carbon atom plus hydrogen atoms are non-metals. Okay? Because molecular compounds is a chemical reaction of, okay, non-polar. Okay. Get the point mga palangga? So this one, CH4. Okay. So now, we go now to the chemical bonding. Okay, molecular compounds, akong ibutang dito sa kilid para sabtan. Non-metals plus non-metals. Okay. Okay, got the point mga palangga? Okay, thank you so much. Okay. CH, carbon is a non-metal, hydrogen is a non-metal also. And now we have hydrogen also, so carbon here, like that. Since we understand that it is not in a straight plane, the bonding, we need to extend already the single bond. Okay, like H, because there are 4 hydrogens. So 1, 2, 3, 4, and we have 1 electron of hydrogen in each hydrogen atom. So 1, 2, 3, 4. And carbon belongs to the group A family. Oh no, group A, right? Then 4. See, 4 valence electrons in the outermost shell. So 1, 2, 3, 4. 1, 2, 3, 4. Now, how you can do the chemical bonding for this? Okay, so you need to react the dots from the hydrogen. Okay, so it's gonna be tadadat ganon. Okay, tadadat ganon, tadadat ganon. Kita po yung mga palangga. Okay, tadadat ganon. Okay, tadadat ganon. Okay, so how many left? 1, 2, 3, 4. Okay, it will also be bound here. Okay, tadadat ganon. Okay, like that. So 1, 2, 3, 4. What will be remaining here? There are 2 carbon atoms. It will be completely shared. Tadadat ganon. Diba? Get the point? So CH4, mga palangga. Okay? You get the point, mga palangga. So 1, 2, 3, 4. So how many options do? 1, 2, 3, 4. This is 4. Okay, 1, 2, 3, 4. And then, okay, 1, 2, 3, 4. 1, 2, 3, 4. It's completely shared already, right? Get the point? This is gonna be CH4. Okay, you get the point? So carbon group formation siya. So carbon 1, 2, 3, 4. 1, 2, 3, 4. Ganon. So it's gonna be CH4. Okay? You get the point, mga palangga? Okay. Any questions so far? So this is the perfectly shared electrons. Okay? But we need to also to understand very well that how many atoms of carbon involved. Nakalok. Okay? Ganun. So, we go to C2H6 ethane, for example. And we go to the C3H8 and we go to butane. What is butane? I forgot the formula. So it's gonna be C4H10. I forgot, but let's do the formula. CnH2n plus 2. This is the formula of hydrocarbon, sorry. So 4 carbon atoms, so 4H2 times 4 plus 2, C4. Yes, it's gonna be C4H10. Okay, if you forget the formula of a hydrocarbon, just use the standard formulation Cn plus H2n plus 2 for the hydrocarbon single bond. And then Cn plus H2n for the double bond, CnH2n minus 2 for the triple bond. Just like this, I forgot the formula for the butane. Okay, so I'll just memorize this formula, then substitute the N, which is 4 for atoms, carbon atoms. Then bingo you can solve, okay? Like that. Ito po yung mga palangga. Ano siya? So CH4 is a equal sharing of electrons. 1, 2, 3, 4. Okay? 1, 2, 3, 4 equal sharing of electrons, mga palangga. Ha? Okay. Like that. Okay. Huwag akong eraser, mga palangga. Okay. O, diba? Dilawan. Hi, shout out, Josh, Alexander, Geraldez, and yes, thank you so much for watching, guys. Okay. Like that. Nakakaloka. Okay. So, methane is an equal sharing of electrons and water is an equal sharing of electrons. How about this? Try. Isa na lang. Let's try, let's say, gasoline. Oh, sobrang dami kayo nito. So, gasoline, 8 atoms of carbon and 18 atoms of hydrogen. So, very lengthy. So, we need to reduce to propane. So, C3H8. Sorry. Okay. So, carbon 3. 1, 2, 3. Carbon. Okay. Okay. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, so 4 electrons in the outermost shell. So first carbon, label. Carbon 1, carbon 2, carbon 3. Okay, like that. You get the point? And then 1, 2, 3, 4, 4 electrons in carbon 1 atom. Carbon 2. 1, 2, 3, 4. 4 electrons of carbon atom 2. 1, 2, 3, 4. 4 electrons in carbon atom 3. Now do the chemical bonding using Lewis dot structures. This is Lewis dot structures. Okay? Chemical bonding. If we speak about chemical bonding, what comes in our brain cells? It is using Lewis the dot structures and following the octet rule. Meaning to say the electrons will not exceed 8 electrons. Okay, like that. Now bond all the hydrogen atom because 8. So 1, 2, 3, 4, 5, 6, 7, 8. And also hydrogen atom has also 1 electron. 1, 2, 3, 4, 5, 6, 7, 8, and connect that one. 1 electron of the hydrogen and 1 electron of the carbon. Ganon. 1 electron of carbon and 1 electron of hydrogen. Ganon. 1 electron of carbon plus 1 electron of hydrogen. Connect. Ganon. And the pattern will follow. Connect. Ganon. So count how many carbon atoms. 1, 2, 3. So carbon 3. Check. Hydrogen. Count. 1, 2, 3, 4, 5, 6, 7, 8. Ganon. 8 hydrogen. So there is an excess electrons for this? Nothing. So therefore we can say propane as a liquefied petroleum gas or LPG. So this is an example of a covalent molecular compound, specifically exhibit non-polar covalent bonding. Okay, it's gonna be like that, non-polar covalent bonding, because there's an equal sharing of electrons. Okay, so just remember in your mind that if equal, there's a word non. Ganun lang. Equal, so, unequal sharing, nan, equal sharing, nan, okay, ganun. Memorize din ka. Oh, equal sharing, completely shared, o nan. And the other one is polar lang siya. So that it will easy to memorize. Okay? Like that. The point. And that is covalent. It takes a longer time to discuss about covalent, right? Nakakaloka. Go, John! Yes! Okay. And now, molecular. What do you mean by molecular? The root word for molecular is molecule. Okay, what do you mean by molecule? For example, I will say 1 mole of a single element, for example, or a substance is equal to 6.023 times 10 to the 23 molecule. Okay, like that. This is the standard. If you try to compute the ratio of mole to molecule, something like that. Now this is through, through data or math. Okay? But if you try to have the definition of a molecule, as easy as this, these are the combinations of 2 or more atoms. Okay? Or multiple of atoms that made up of one compound. Okay? Meaning to say, several atoms adjoined, adjoined, combined, united, reacted, okay, like that, in union, like that. What else? A lot of synonyms for this, right? As long as they are compacted with each other to produce one single compound, specifically the molecular compounds. So these are called molecule. Okay, so we can say molecule is larger than an atom because you bond all atoms within it to produce a compound, right? Okay, that's gonna be a molecule. Okay, but take note, molecular is always non-metal and non-metal. Okay, get the point? Don't be confused. So if you're trying to differentiate and to identify, you can now identify, right? Automatically without question, right? Now, that's molecule. And then molecular is only an adjective, okay, describing the behavior of a molecule. English, right? So molecules, these are the molecules, and if they act according of being a molecule itself, then it will become molecular, meaning to say an adjective describing these molecules, how they behave in a certain chemical reactions or in a chemical bonding, something like that. So that's why molecular. The root word is molecule, noun, and then molecular is an adjective. Okay? Like that. And the last term is compound. What is a compound? So things like this, we need to differentiate word for word and terminology to terminology. Okay? So that we can understand prior to discussion, right? What is a compound? Anybody? Charot. A compound, of course, several elements or two or more elements chemically combined with each other to produce a compound. Whether it could be either molecular compound or ionic compound. Something like that. Okay, I will teach you there are only two types of compounds, no other. Ionic compound and molecular compound. Okay? At least with a question in the future we'll say, oh, how many compounds? How many types of compounds? Only two. Okay? Do not create another type, only two. Ionic compound and molecular compound. Okay? Ionic compound is metal and non-metal. Okay? Take note, metal and non-metal. Okay. So, in this topic, we need to understand really what are those metals, what are those non-metals, so that we can easily distinguish molecular compound over ionic compound. Right? It's gonna be like that. So, nadaog na, nahurot na natong define ang covalent molecular compound. Right? Okay. Now, we go to the properties of molecular compound. Properties. Okay. Properties, charots. Okay. Properties. What do you mean by properties? Again, we will review the properties. So it's going to be a physical property or a chemical property. Okay, so obviously chemical property deals with chemical reaction, of course, chemical changes, of course, chemical dissociation and ionization, chemical reactions, of course, like that. Okay, but for the physical properties, so much. Okay, we have, for example, boiling point, melting point, freezing point, like that. So surface tension, specific gravity, viscosity or diffusivity, something like that. Okay, we have also the measurement of the length, volume, like that, the width, like that, the amount of the substance you put into the container. So these are also properties. What else? The flammability, okay, like that. Okay, the explosivity, because the reactivity is chemical property, okay, like that. Okay, what are the properties? There are a lot of properties. So the properties are categorized: extrinsic property and intrinsic property, something like that. You get the point? Intensive property or intrinsic property, and you need to know that also. But we are not concerned with that. We are only concerned for the properties general itself. We will not categorize here. So, what are the properties of a covalent molecular compound? We're not particular whether it is a chemical property, physical property, as long that it is one of the properties of covalent molecular compound. Okay? First, guys. So, if you know these properties, it's very easy to detect with the ionic compound. It's only the reverse. Right? I will tell you something. Diba? Nakakaloka. Okay, so property number one, okay, the melting point and the boiling point. So magpares din siya ang melting point and the boiling point. For example, in English, war, peas, like that. Black, white, like that. Okay? So, ugly, then beautiful. Humble, arrogant, something like that. Weak, strong, like that. Tall, short, like that. Fat, then thin, T-H-I-N, like that. So, it's, okay, the opposite. Okay? Just like melting point and boiling point. Okay? So, the melting point and the boiling point of the molecular compound or covalent molecular compound is low. Low NP, Manny Pacquiao. Charot. Diba? Low NP and BP, blood pressure. Sorry, I'm just joking. Okay, low melting point and boiling point. So, meaning to say, the ionic compound has a higher melting point and boiling point because it's the reverse. Okay, it's very easy to detect and to memorize, right? Okay, now you can prove this in the experimental analysis in the chemical laboratory in a small scale proof analysis. Proof meaning confirmation test and analysis. How it will really undergo the low melting point and the boiling point, of course, right? Through heating, something like whatever. Okay, like that. Now, another is, this is mostly not to conduct electricity. Okay, not to conduct electricity. Meaning to say, normally or naturally. Not to conduct electricity, naturally or normally. Meaning to say, you did not introduce other substance. By its nature itself, not to conduct electricity. It's another story. You will say, you will add something. Okay, you get the point? By its nature only, naturally, not to conduct electricity. Okay? Ganon. What else mga palangga? Okay? Soft, softer, meaning soft than ionic compounds. Wow. Okay. It will justify on the first property, low melting point. Right? If it is softer, then it is very easy to melt compared to the ionic compound, right? Melting under the burning process, something like that. Or heating, whatever. Then if the metal becomes soft in just a matter of 5 minutes, then it is softer, right? Softer than ionic compound. So low melting point. It matches the first property. Okay, what else? Okay. Less soluble. Okay? Like that. So less soluble than ionic compound. So meaning to say, if you add water, it will not dissolve completely. Though it will dissolve slowly and gradually, but not completely because less. It's not entirely not soluble. It's not immiscible. Immiscible meaning insoluble, the same meaning. Okay? So it's not entirely insoluble, but only less. Okay? Less soluble than ionic compound. Okay. Number 5, okay, is we have non-flammable. Okay? Not flammable. So review. Let's review because it's quite confusion. It will say not flammable. As what I remembered, okay, just like the situation, you have to think before putting up. Okay, let's say we think non-metals. We need to make sure if it's really non-flammable. Maybe reverse. Okay, if I have non-metals, and mostly of the metals are, okay, oxygen is the most abundant non-metal, right? And then oxygen is reactive. So, by the way, it's flammable. Okay? Things like this, if you forgot for a quick second, then you have to think critically, oh, some examples, and you have to change. Okay, like that, it's normal process, right? Okay. My best example kasi sa non-metals, oxygen. And then I forgot, then, oh, it's really flammable because oxygen is flammable. Things like this also will be helpful in your memorization. Okay? Not only entirely memorizing without understanding, because if that is the case, you forgot, then you can no longer justify what is really true and correct during your explanations. It's flammable, my guy, mga kapatid. Flammable siya ha. Because oxygen, manggod, is most abundant element in the planet Earth. The most reactive element in the planet Earth and the most abundant element in the planet Earth is oxygen. And oxygen is flammable and reactive. So, since oxygen mostly involved in covalent molecular compound, then of course, most of the covalent molecular compound are flammable. Okay? Not flammable. And of course, the ionic pala is not flammable. It's the reverse. Things like this, ha? Okay, ganon. Those are the properties of covalent molecular compound. Now, I will give you an example for this, but before going to give you an example, let's enumerate and let's list the nonmetals in the periodic table. Of course, so that we can easily give an example, right? Okay, there are 17, right? 17 nonmetals. Okay, what are those? Okay, we will start with hydrogen. Hydrogen is the only nonmetal in the group 1A, very special. Okay, hydrogen. Okay, now, then we go directly to the group 8A or the group 0 in the periodic table, which is the noble gases. Enumerate them all because they are all nonmetals. Okay, helium, neon, xenon, krypton, argon, and radon. Okay, Rn, right? And then also in the group 4A, we have only, I think we have only carbon. Okay, carbon. Okay, and then in group 5A, this will be based on my memorization before. Group 5A, I think there are at least, for example, two, nitrogen and phosphorus. Okay, and in the group 6A, these are the most common, the most popular. Oxygen, sulfur, I think so, right? Correct me if I'm wrong. My gosh, selenium. Okay. In a way, let's drop it does not belong to the group later on. Okay, beryllium, like that. Okay, and now the group 7A also, the halogen group. Okay, the halide family, the fluorine, chlorine, bromine, iodine, and astatine. Ganon. Astatine is 80, right, mga palangka? Symbol, I forgot. Maybe AS, maybe 80, but you know, it's not really that major problem. I think 80 siya. Just review and correct me if I'm wrong, ha? Okay, because I cannot also memorize everything in the periodic table. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Let's drop 2 here. Okay, because it's stated only in the theory, 17 nonmetals. Okay, so how can we drop here? So it's gonna be, I don't think so, beryllium. Okay, and I don't think so, astatine. Based on my, common understanding in my 5 years of basic chemical engineering, I don't encounter really this astatine and beryllium being a nonmetals, right? Okay, like this is gonna be this. Hydrogen, helium, neon, xenon, krypton, argon, radon, carbon, nitrogen, phosphorus, oxygen, sulfur, selenium, chlorine, bromine, astatine. Sorry. No astatine, sorry. Nakakaloka pala. Okay, now, list all their atomic weights and atomic mass. Okay, hydrogen, 1.008 atomic weight and atomic mass. Atomic. Helium, mga palangga kong hitad. Helium, what is the helium? Okay, like this. Helium is 4, right? Correct me if I'm wrong, mga palangga. So, okay, I will think again. Helium is 2, why? Oh, it's 4. Okay, helium is 4. Okay, like that. Okay, neon is 20.18. Okay, if I will be in, stoppage for a while, I need to think. Okay, maybe my memory fails. Okay, xenon, like that. Okay, xenon is gonna be, 83. Okay, 0.80. Okay, wait, I will stop for a while. It's not 83.80, it's really 138.3. You should be careful because once it will be wrong, your molecular mass, your molecular weight, and molar mass will be wrong. Okay, krypton is 83.8. Because I don't arrange. When I memorize this in high school, I don't arrange. Actually, it's easy to arrange. If you arrange this one, it will be the increasing, atomic mass actually. So there will be no difficulty. But it's also difficult to memorize at the same time you will arrange. Right? So that's why. Okay, so argon, 39.95. Radon, my favorite, triple 2. 222. Okay? Carbon, oh my gosh. Carbon 12, the most common, right? Nitrogen, ganon, 14. Phosphorus, 30.97. Oxygen, 16. sulfur 32, selenium, chararat. Selenium is gonna be 78.96. Okay? Fluorine is gonna be 19. Chlorine is gonna be 35.5. Okay, bromine is gonna be 79.70, and iodine is gonna be 126.90. So these are the atomic masses and atomic weights of the nonmetals. Okay? So that it's easy for us to give examples of the covalent molecular compounds, and at the same time, it's easy for us to compute their molecular masses, molecular weights, or molar masses. Okay? Things like this. Okay. Now, since I cannot memorize all the examples for this, guys, anyway, I can create also if I want to. Right? If I want to, I can create because I have already non-metals and I have to react only with the non-metals and other non-metals also, right? For example, carbon. Carbon is very popular. Carbon. Then you have to react with another non-metals. For example, chlorine, fluorine, bromine. O, diba? Okay, so ganon. So I can say, for example, magbuhat lang ko, guys. Okay. Okay, magbuhat ako mga examples. So number 1, carbon tetrachloride. Wow, ganon. So but before going that, I need also to introduce the technique how to name the, this covalent molecular compound. So first we need to introduce prefixes also. The prefixes also are not only applicable in math, but also in chemistry. Okay, math. For example, DC, centi, like that. Mega, micro, ganon, giga. Those are prefixes in math. Okay? But we have also to apply here in chemistry. So we have mono, okay? Di, okay? Tri, okay? Tetra, ganon. So that's why carbon tetrachloride. This is for 4. Okay, my first example. Okay? We have penta. Nakakaloka. 6 hexa. Okay. 7 hepta. 8 is octa. Okay. 9 is nona. 10 is deca. Okay. Right? If you remember also the decagon. A polygon composed of 10 sides. Because deca is 10. Things like this. Okay. If I have, for example, heptagon. Okay, a polygon composed of 7 sides. Okay, not necessarily equal as long as it contains 7 sides. So heptagon, like that. Octagon, the most common. Okay, we have also 8 sides. A polygon consists of 8 sides. Octagon. So if it is more than one side, automatically without question, that is technically a polygon. Because poly means multiple, more than one, more than two, like that. The same as polysaccharides, composed of saccharides, sugars, glucoses, fructoses, sucroses, riboses, and all types of sugar we encountered in this planet Earth. So if we bound them together in one big structure, that is what we call as polysaccharide, because these sugars are saccharides family. You get the point? So, for example, me, I am a Nepomuceno family. So we have also a lot of Nepomuceno. Just like this, these are saccharides family. Their last name is saccharide. And then the son, the daughter, like this, we have the glucose, sucrose, fructose. So these are the saccharide family. So, since there are so many in that family, they are called polysaccharides. Because poly means more than one. Any questions so far? Wala na. Okay, so we have carbon tetrachloride. Number 2. Okay, say for example, I have, nakakaloka. Okay, carbon hexachloride. Wow, carbon hexachloride. So CCl6, right? CCl6. Okay, ganon. Then for example, sulfur trioxide. Ganon, SO3. Okay, what else? Okay, for example, dinitrogen heptaoxide. Dinitrogen heptaoxide. So 7. So O7, right? Like this. Guys, covalent molecular compounds are very enjoyable. You can make your own as long as you will follow the prefixes. Because the charges are not an issue for this. Compared to ionic compounds, we need to determine really the oxidation state, the oxidation number, the charge. It will become an issue during the net electrical charge combination in your overall oxidation reduction. Because ionic compounds undergo the process of oxidation and reduction. But in here, it's not an issue of oxidation and reduction because these are all molecular compounds. So it's easy to formulate our own chemical compound, something like that. As an example only for the purpose of discussion. Okay? Like that. And then I have also to say, my favorite also, the laughing gas. The laughing gas is N2O, meaning the nitrogen oxide. Okay? And I have also to say hydrocarbon, let's say LPG, liquefied petroleum gases. Could it be butane and propane? Okay, like this. So choose among them because both of them are LPGs, liquefied petroleum gases. Could it be butane or propane? It's up to you, but I need to choose butane this time. So butane is gonna be nakakaloka. So C4H10, okay? C4H10. Correct me if I'm wrong because we have propane C3H8, but you know the number of atoms of hydrogen is in ascending order by 2 only. Since 4 is next to 3, then we can also say H10 because the hydrogen atoms of propane is 8. So plus 2, 10. Something like this. If you forgot, you will analyze, right? Okay, number 7. What else? Actually, I like YouTube, guys, no? Okay, ammonia. Okay, ammonia, NH3. But we can never say nitrogen trihydrogen. So we will exclude ammonia because in naming, it will not be okay. Charot. Okay, charot lang. Okay? Diba? So we can say also, may mga name guys pa. For example, what else? Benzene is not because it's not really. Kanilang siya 6 guys for actually so many. Okay? You get the point? Mahulog atong oras if we try to enumerate all. So, and others. Ganon. O, diba? Ganon. So, carbon tetrachloride. Tetra because 4. Carbon hexachloride because 6. Chlorine. Sulfur trioxide. Tri because 3 oxygen atoms. Okay? Dinitrogen heptaoxide because 7 is hepta and 2 is di. Okay. Dinitrogen oxide because 2 is nitrogen and oxygen nothing. So if nothing, just only oxide, fluoride, like that. Okay, so this one, butane. Butane also will not hold through because actually we'll say tetracarbon logon, tetracarbon decahydrogen. There's no things like that also. Sometimes you need to think, though it will be okay if you forced, but that is not commonly expressed in that way. Okay, you really remove butane. Nakaloka. Diba? Oh, ganon. So, this will be the naming of the covalent molecular compound. Don't be confused. Some books, based on my experience, in my 5-year study in chemical engineering in CIT University, before that's only an institution, right? I found out that the molecular compound is just the same with covalent compound. Don't be confused. Covalent compound is just the same molecular compound. That will only trick you up. It's just the same. Or it would be more technically precise if you use complete the terms. We have covalent molecular compounds because these are all driven by chemical bonding, specifically the covalent bonding. Meaning the movement of electrons could either be, it will be transferred through sharing of electrons. Any questions so far? Nothing, right? Okay, it's gonna be like that. Any question for this covalent molecular compound or molecular compound or covalent compound only? So these are the terms that you need to perfectly engrave in your brain cells. Wow, engrave talaga. Okay, it's gonna be like that. So, if you try to, okay, there's also another issue for this in the covalent molecular compound, a positive issue, positive or negative issue. So, it doesn't matter. Okay, so, since we have 17 nonmetals, we have also another version of nonmetals. It's gonna be the, you have an idea mga palangga? Oh, mga kakamping, dilawan. Okay, I'm wearing yellow now. Okay, dilawan. Charot. Okay. So, sorry. I love yellow and pink. Nakakaloka. Diba? But this is not a symbol of political party, but honestly and naturally, I love yellow and pink. Okay? Nakakaloka, diba? Okay, so if we have 17 nonmetals, okay, we have also a lot of nonmetals through other, other criteria. Okay, we have the polyatomic anion. Okay, for example, sulfate, ganon, chubachucho. Okay, sulfate, -2 charge, phosphate, -3 charge, manganate, ganon, di ba? Okay, permanganate, and for -1. Manganate is -2 na siya, parang ganun siya. Okay, dichromate, Cr2O7, -2, ganun, chupa-chuchu. Right? Nitrate in O3, -1. Nitrite in O2, -1, right? Hypochlorite, okay, hypochlorite, HClO, and -1 only is the charge for hypo, right? You can still remember peroxide. Oh my gosh. Peroxide is O2, -2, right? Peroxide. That's why we have hydrogen peroxide, aguaxinada. Ganon. Okay? So what else? So, ibutang-talang mo lang ni siya. 1, 2, 3, 4. Actually, there are more, right? 1, 2. We have also oxalates. Ganon. So 1, 2, 3, 4, 5, 6, 7, 8. We have also silicate, right? Is iO2 -2? I think so, yes. Okay. Silicate. Okay. Now, you can also add this to the non-metal. And this is still covalent compound or covalent molecular compound, something like that. Okay, for example, if I will add, carbon, carbon, sikat yun kaya si carbon. Ang sikat no, si carbon, si hydrogen, si oxygen, si nitrogen, and si sulfur. These 5 are very common. Okay? Carbon, hydrogen, oxygen, nitrogen, sulfur. Carbon, hydrogen, oxygen, carbohydrates family. Carbohydrate, carbon, hydrogen, oxygen, nitrogen. Like that. Protein family. Like that, protein. Okay? Kung na siya nitrogen, protein. Something like that. Okay? You got the point, mga palangga. So it's gonna be like that. Okay, so if, for example, again, because I love carbon atoms, charot. Okay, so let's say carbon. Okay, can you add carbon to nitrite? Like this? Because molecular compounds are non-metals plus non-metals man siya. Okay? Yes, but you have to be extra careful. Okay, because there's also sound awkward, though it can be done, but sounds awkward. For example, nakakaloka. So, on the spot ni siya ha. Carbon phosphate. You cannot never heard carbon phosphate, right? In my entire life, I've never heard carbon phosphate being a chemical engineer. I don't hear that. If you try to force that one, then it can be due to the technical, theory, but it's not happening all the time, meaning awkward. Okay, like that. So I'm gonna choose the most active and reactive. So it's gonna be the peroxide, right? Okay, like that. So carbon peroxide. Ganon. Okay? So, i-add lang mo sa carbon, then makaproduce ka of molecular compound. Something like that. Okay? Ito po yung mga palangga. Yes. Because the metal siya. Okay? You have to enumerate the other non-metal also. Daghan man kayo siya guys no, mga fluorine, bromine, akong i-mention kanina. Then you have to add this only. Because non-metal plus non-metal by theory. So it is molecular compound covalent. I don't have to enumerate, alright? As long as non-metals plus non-metals. That is molecular compound, covalent compound, or covalent molecular compound, mga palangga. Ganon. Okay, any questions so far? Thank you so much for watching, mga dilawan kong kapatid. Oh, Jason Talaed, Michelle Banawa, wow, Alexander Geraldus Lapitan. Oh my gosh. Thank you so much, mga palangga. Josh Rodas, ako mga fans. Charot. Diba? Okay. Thank you so much for watching for this topic. Okay, covalent molecular compound. Then, for example, guys, if I have, paano ko matakbaw, no? So, if I have gasoline, okay, gasoline, the chemical formula of gasoline is 8 atoms of carbon and 18 atoms of hydrogen. So, this will run our vehicles, cars like this. And this is belong to the octa. Octa. Because this is 8. Meaning to say this is octane. Okay. In organic chemistry or chemistry, we can say, if you refer to octane, that is specifically the gasoline itself. If I will say, oh, I will put octane in my car, it's acceptable that this is already gasoline. Okay? Though others will not be familiar because that is not their, profession, but we as chemical engineers or chemists, something like that, oh, it's gonna be like that, we will understand. If I will tell my niece or nephew, put octane in my, in my internal combustion engine of my car. Then he cannot understand normally because he's not a chemical engineer. Then you have to explain that octane is also a gasoline. In that way, he will put the gasoline or whatever. Or if you go to the petrol station or gasoline station, then that's it. Okay. You will say, put octane, let's say 24 liters of octane, and in the gasoline station, we cannot understand. Okay, just that octane is just the same with gasoline. At least, you will be relevant in the society by teaching a term in which most of the people don't know. Right? You are educating something unique, amazing, because they did not know about that. Okay, so my friend, gasoline is an octane. It's just the same. Ganon. So by the time you will go to the same gasoline station or petrol station to put gasoline in your car, then you can easily understand that that is the same thing what you are referring to because you already educating him before, something like that. You get the point that octane is technically the same as gasoline. Okay? It contains 8 atoms of carbon and 18 atoms of hydrogen. Ganon. So what will be our chemical bonding for this? We will try. Okay, 8. So 8 kabuok. 1, 2, 3, 4, 5, 6, 7, 8. Ang Lewis dot structures, mga palangga, mo follow siyang octet rule. In each chemical bonding, it will never exceed to 8 electrons. Take note, in each carbon to hydrogen linkage or carbon-hydrogen chain. Okay? We are calling that carbon and hydrogen chain or linkage. Ganon. So, 18 means the totality, but it doesn't mean in every carbon atom. Okay? So carbon 1, or label, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, carbon 7, carbon 8. This is only for the purpose of discussion, mga palangga, because the true numbering of carbon atoms in organic chemistry will start from the right. Here, actually, 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's why we have the term, omega. The omega-3 fatty acids, the counting in organic compounds will start on the left. So we have omega-3. That is, carbon-3 starts from the left in naming. But the natural naming in organic chemistry, it will start in the right. Let's say we have counting 1, 2 decanoic acid. If you can remember it, if you have an organic chemistry subject, right? Okay, but in here, for the purpose of discussion only, it doesn't matter whether it is in the left, it is the right, as long as you can present your discussion. Okay, for the purpose of explanation only. Okay, for the carbon, we have 4 valence electrons in the outermost shell. Wow. So 1, 2, 3, 4. Ganon. Represented by a dot. That's why Lewis dot structure. 1, 2, ganun, chupa-chucho, di ba? 3, 4, ganun. Buta nga rin mga 4, uy, ganun. Ano na siya. Wow. Diba? Ganun, oh. Di ba makalingaw siya? O, ganun. Oh, ganon. Oh. Now, supply hydrogen atoms in each carbon. So, 8 is 1, 2, 3, 4, 5. Mga palangga. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So, perfect. Hydrogen atoms 18. Ganon. Now, hydrogen atom has one electron in the outermost shell because it is in the group 1A in the periodic table. Okay, so we put one also electron. And connect. Oh, connect, make a one line straight, connect the dots, okay? The dots, that's why dot structures, right? Okay, di mo makalingaw? Okay, and then connect also the dot in between the carbon to carbon atoms, bonding. Oh, oh, perfect! This is now your gasoline. Okay. As you can imagine, there's a lot of hydrogen in your gasoline. When you put in the car, in the internal heat combustion engine of your car. Something like that. Oh my God! My God! 18 atoms pala siya, of course, right? Now, is there any unpaired electrons remaining? Completely are being shared. So this is non-polar covalent bonding. So your gasoline is a non-polar covalent molecular compound. Wow, ang haba. Again, non-polar, so non-polar covalent molecular compound. So meaning to say entirely flammable. Okay. Because this is one of the property of a molecular compound or covalent compound. That's the reason behind technically why gasoline is flammable, because it is non-polar covalent molecular compound. Okay, due to its property, physical property, aside from the chemical property, right? The reactivity. It's another story, the reactivity. Okay, the chemical reactivity also of gasoline is very high. Okay? Get the point? Mga palagaman na siya ng tabo. Okay? Di-show na ako ang lilis dot structures. So, why octetrosutero? Because in each carbon, it will not go beyond 8 electrons. Okay? That's why octetrol. When you do the banding chuba-chucho, di ba? Ang ganon. Okay? Wala siya, guys. Any questions so far? So, nindot siya ang molecular compound kaya ma-attach mo ang organic chemistry here. When you discuss the topic of covalent molecular compound, you will attach the hydrocarbon chemistry topic or organic chemistry. So, 3 lang ito hinumduman, guys, ng mga 3 formulas in hydrocarbon atom hinumduman per me so that we can extract what is really the molecular formula. So, we need to follow this. CnH2n. Oh my gosh, I memorized this in high school. Okay, CnH2n plus 2. This is for the ANE family. ANE single band. Okay, like this. In fact, okay, gasoline is a single band. Okay, like this. And then we have CnH2n, which is the double band ENE. Ganon, double band. And we have also the CnH2n minus 2. This is YNE family. Okay, this is triple bond. Okay, like that. Okay, ganun mga palangga. For example, if I have an HDPE type of a pipe, HDPE, that is high density polyethylene. Okay, that is one type of your material banded together to create an HDPE type of a pipe, something like that, used in fire water line or whatever, potable water line. Okay, it's gonna be HDPE and LDPE, and you have also the PVC, polyvinyl chloride, meaning to say it is banded with too much of vinyl and chlorine. That's why poly. Okay? And then LDPE meaning low density polyethylene. It refers to the density, low density. Okay? It has to do something with a specific gravity. Okay? With the ethylene, of course. Okay? And then poly also, it is banded with too much ethylene. Ito yung poly. HDPE, high density, meaning it has to do something with the specific gravity, high specific gravity and high density. So poly also, so a lot of ethylene there. And now our question, what is the formula of ethylene? We need to extract this because this is the K term in this HDPE and LDPE, the ethylene component. Okay, something like that. Polyvinyl chloride also. The chloride constituent in this particular compound. Like that. Okay? So, mga palangga, muna siya ng tabo. So, basically, these are all molecular compounds. Okay? Or hydrocarbon compounds. Okay? Like that. So, for example, if I have polyethylene, so there's a lot of ethylene. So, what is the formula of ethylene? Okay. Ethylene. Meaning, it is in the second part. 1, 2, 3. Second part, mga palangga. So, ethylene. Meaning, saying E-N-E. Okay? E-N-E. So, double band, use this formula. CnH2n. The N there, the small letter N, represents the atoms. The number of atoms of both carbon and hydrogen. Okay, now, ethylene. Okay, now, the word ethyl, meaning this is an alkyl group in the number 2. Because we have the methane as methyl in number 1. So, for example, methane, CH4, natural gas. This is methyl. So, methyl meaning this is an alkyl group ready to be bonded with other compounds as well. Or organic or other compounds, something like that. And then we have also ethyl. Ethyl. That's why we have ethyl. So this ethyl is an alkyl group also, but 2 na siyang carbon atoms. So 2 carbon atoms. So we have now 2 carbon atoms of high carbon. Ganon. Now in this case, as long as you know already the carbon atoms, you don't have to worry the hydrogen, something like that. Okay, because it can be followed when you use this computation. Okay, number 2 kay E-N-E man mga palangga. In case of the HDPE and LDPE, like that. Okay, so Cn. So N is 2. This is 2 atoms, right? So C2. Ganon. Hydrogen, 2 times, again, 2 atoms of carbon. The 2 atoms of carbon are the bases always. So 2. Ganon. So it will become C2H4. So this C2H4 is the chemical formula of ethylene in your HDPE and LDPE. But how heavy, how light is this? That will become now the categorization of your HDPE and LDPE. Because this HD part and LD part is only to the type of the density. Okay? But you use the same ethylene in your raw materials. But you try to categorize that basing on how heavy and how high light is that through density, ang gibugaton. That's why high density polyethylene. But this is the main raw material, ethylene, this chemical formula like this. But this is bonded a lot of times, several like this, because this is poly. So more than one ethylene as a raw material banded to produce in this HDPE that is very heavy because high density. Now, if we have low density, the light, but the same thing, a raw material ethylene is bonded together so many times because poly, P-O-L-Y. That is an adjective, poly. Okay? So we can know, that's poly. It's only a description that signifies more than one. Okay, something like that. Or multiple, something like that. Okay, or several, various, many, okay, plenty. What else? So these are the same, right? Okay. Wala siya ang ethylene. No, C2H4. O, ganon. Get the point? Now, if I have acetylene gas, it is a flammable gas. See, acetylene is a flammable gas because it is a molecular compound. That is one of the property of covalent molecular compound, right? Technically, it will follow. So basically, if you have a theoretical idea, when you buy a chemical, not necessarily you will look for the, for the packaging and the, the meaning of the description because you know already. Once you know it is a molecular compound and covalent, no need to read, I know that already that's flammable. Because in the theory, it states that if it is a molecular compound, non-metal plus non-metal, automatically, without question, that is flammable. Even though you will not read the description there, flammable or not, you can identify. We as chemical engineers, automatically we can, this is not flammable, it's flammable. Because by the theory alone, technical concept for that chemicals, we know already. Okay? For that. Except also to others who are not clearing that match, only studying for the purpose of passing the grades. If you're really studying because you want to apply that in the real life scenario, you can apply that in a day-to-day life, you can use that in the reality or in the real world, then you can easily understand something like that, okay? Get the point. It will retain in your brain cells. Or for example, if we have acetylene gas cylinders, okay? So, I know already what's the formula, but this is the purpose only for the discussion. Okay, so acetylene. Nakakaloka. So, put that in a statement. Acetylene. Nakakaloka. Acetylene. Okay. There's a word of E-N-E. There's a magic here or miracle. I will share to you the miracle and the magic later. Magputas ako kape mga palangga. I will show you why acetylene generate a miracle or an amazing situation. Charot. Nakakaloka. Okay. Ganon. Guys, through experience and through, practice, problems, reading a lot, you can also notice other things in which you don't gain in your classroom instruction. Even though the teachers did not teach you to that, you can learn something. Okay, that others also don't know. Something like that. You get the point? So that is what we call maximization of your academic potential. Okay, like that. You get the point. So acetylene ha, we know sa coffee guys, but while waiting for the water to boil, charot. May ganun talaga. Water to boil, charot. Okay, acetylene, E&E family, double band na yun mo. Dara. Kaloka. O diba? So, acetyl. What do you understand about acetyl? We have also acetaldehyde, an aldehyde family, right? If you can still remember, the aldehyde family, the ketone family, ganon, chuchu, ganon, right? So, aldehyde family is gonna be, based on the memorization, carbon, double bond oxygen, H, and R here, alkyl group. So, this is gonna be the aldehyde functional group. Like that, things like that, okay? So I don't have to discuss more on hydrocarbon chemistry because our topic is not really hydrocarbon chemistry, right? Okay, narelate lang siya. Okay, so we have acetylene, A na yun. Ganon. Basta hydrocarbon mga palangga, mo focus ang inyong brain cells sa last 3 letters. Okay, last 3 letters. For example, methane, butane, propane, like that. And then there's also propene, butene, like that. Gahi. Meaning to say E-N-E na siya ko. Kung kuan sa kay luya, butane. That means Y-N-E. So better write it because the pronunciation matters a lot. Okay? Sometimes you can misinterpret the butane to butene. So better write that in a blank sheet of paper what you are referring to make it precise, right? We will say, if you are studying, for example, I have propane, I will give you the propane. So what's the spelling? Because the pronunciation, will matter a lot also, guys. Because you will give him another hydrocarbon chemical. If you give him the methane, and then actually you are referring to methane. In this case, pronunciation and diction matters a lot. So the only way to solve that is to put that in a blank sheet of paper. And your teacher will say, also Tero, buy methane in the public market. For example, only for the purpose of discussion. Okay. So you will interpret, ma'am, methane, or methane. Oh, di ba? So you have to say, ma'am, please write in the paper. And you will say, oh, okay, this one, methane pala. Then you will go to the store and you will buy methane. Ganon, di ba? Or natural gas. Example only, right? Okay, so if there's an issue of the pronunciation and, for this. So the only way to solve that is to put in the paper. Okay. Like that, or to label that in the packaging. So this is acetylene. So because we have also acetylene. Ganon. Diba? So since this is ENA, acetylene. Gahi. Okay. So meaning to say double bond. Oh, see here? Double bond. Okay. Now what is the chemical formula? Let's say I don't know. I forgot. For the purpose of discussion only. Okay? Mga palangga. Detach na ako because it's molecular compound. Okay? Okay, because as I told you over and over again, hydrocarbon compounds are all covalent molecular compounds. That's why I relate this hydrocarbon chemistry topic to the covalent molecular compound in general chemistry lecture. Ganon mga palangga. Diba? Nakakaloka. Yun sa coffee. Ang sakit kong brain cells. Di ba? Kapag akong hitad. Nakakaluka. O di ba? Wait for a while ha. Last na lang na siya guys. And akong stop ang video. Okay, mabuta sa other topic. Charot. Hello! Mga dilawan kong kapatid. I'm wearing yellow right now. Di ba? Diba? Char. Coffee, mga palangga! Kulitan! Uy, char. Diba? Coffee for life. But this is only coffee. Sweet. Bahala na. Nag-crave ang akong tiyan. Okay, og sweet. Charot! Did you batabang? Iba sa why sweet, diba? So, okay. Oh my gosh. Wow, the aroma tastes so good. Smells so good. Wrong grammar. Smells so good, the aroma. Manotis gina yun ako do. Diba? In fairness. Thank you so much! Okay. Oh, nakakaloka yung mga friends ko dito. Oy, Engineer Renanti Sayabok. Thank you so much for watching. Ma'am, uy, nakakaloka. Silingan. Ma'am, Evelyn Ingiyo. Wow, you are watching. Thank you so much. O, diba? Mga silingan man na sila, guys. Okay. And then the other also. Okay, mga kababayan, regular sila. Charot! Diba? Thank you so much for tuning in. Okay, now going back to acetylene, flammable, gas. Okay, ganon. Charot. Nakakaloka. Okay, ENE family, so we have CnH2. And let's prove ha. Okay, ganon. So, carbon atoms is acetyl, guys, it's the same with ethyl. Two carbon atoms, ethyl, acetyl, ganon. You get the point? So, acetyl group. Okay, ganon. So, two siya. Acetyl. Okay. Then, we have also the acetylene and we have also the, acetic. You remember acetic acid? So, it's just the same here. Acetyl and acetic. Okay, acetic. Meaning two talaga siya, guys. Right? Or, we can have also ethyl. But we don't have ethic. Okay? You should also be extra careful. Okay? If we have acetyl, we have acetic. If we have ethyl, we don't have ethic. Good the point. Acetyl is more on organic chemistry, and acetic more on inorganic chemistry. The basic acid. Okay, not really the carbonyl acid COOH functional group in organic chemistry. We are only dealing with H plus, okay? Hydronium ion also, H3O. Okay, now acetic, meaning 2 carbon atoms. Acetyl meaning 2 carbon atoms. Ethyl meaning 2 carbon atoms. For example, if I have ethyl alcohol, okay, ethyl alcohol that we use every time as an antiseptic to, to kill and reduce the bacteria present in our wounds, like that, cuts, bruises, lacerations, or any kinds of wounds, right? We need to wipe it with an alcohol. Usually we use the ethyl alcohol, right? Because that is antiseptic. Okay, like that. So ethyl is 2 atoms. So now, since you are referring to alcohol, OH family, right? So you will say, OH, na kay OH, na nasa kay 2 carbon atoms, i-attach nyo na sa here. So daog dayon. Muna din ka, C2H5OH. That's so dayon. And this is the formula of ethyl alcohol or ethanol. Okay? You will just put OL because that is OL family is also an alcohol family. Okay? I think including the cholesterol. Cholesterol is an alcohol family because it ends with OL, but will not behave like an alcohol. For example, just like helium I told you, that is belong to the same group with alkali metals. Okay, things like this, guys, they will be in the same group, but they will differ in characteristic and property. Just like the cholesterol. Cholesterol is an OL family or alcohol family, but it will never act the same as an alcohol like ethanol, propanol, okay? But I'm telling you, cholesterol is an alcohol family. Okay? You get now the differentiation? Okay, like that. You get the point. For example, okay, I'm wearing a yellow t-shirt that supports Lenny Robredo. Okay? Then I will not act as a Dilawan. But I'm only wearing yellow. It's just like that. You get the point? Only right like that. There's a lot of example for that, guys. Okay? You get the point? For example, I'm going with them and they are not my friends, like that. And I just acting like their friends because I am in their group. But actually, I'm not their friends. Just only for the purpose of, civil friendship, something like that. That's to show respect that we are the same group. Okay, Filipino to Filipino, okay, Pakistani to Pakistani. But the Pakistani will also associate the Filipino, something like that, right? Pakistani will associate like that, but you have not the same characteristic, behavior, and culture, but you are in the same group. The same like this also with the OL family. Cholesterol is an alcohol family, but will not act as an alcohol. You get the point? So things like this we need also to inject in our analogy, in our discussion. Okay? And it's normal also, right? Okay. Now, OH, ethyl alcohol, ethanol na, di ba? Ang two atoms of carbon, because I say ethyl. Ganon. Okay. Now, for the acetic. Charot. Acetic also 2 carbon atoms. What is the formula of acetic acid? So you have now in your minds, there are 2 carbon atoms. Ibutang na yun ang carbon atoms. C2. Ganon. And then, this is an acid because acetic acid. Put H. Ganon. Like that. And now you will remember the polyatomic, which is acetate. And then we will put C2H3O2. So this is acetic acid formula. The vinegar we use in our kitchen. That is acetic acid. There are 2 carbon atoms in it. You cannot just see, but it will be behaving in your frying pan, in your, whatever, when you use that vinegar. Okay, in your system. There are 2 carbon atoms. So HC2H3O2 is the chemical formula of your acetic acid. Now we go to the acetylene. So 2 also, right? So since this is hydrocarbon, what you have in mind is the combination of carbon and hydrogen. I will combine first the carbon and hydrogen. Carbon and hydrogen. Because the definition of hydrocarbon is a combination of carbon and hydrogen atom. In the first place, theory. Okay, so CH. Your only problem now, you cannot determine the atoms. But you have an idea that acetyl is a 2 atoms, the same with acetic, ethylene. You have to put the 2 here. Ang imong problema kanina lang subscript sa H. You should know. But take now the formula of hydrocarbons sa organic chemistry na ENE man siya, di ba? Acetylene. CnH2n. Now substitute the 2 atoms here. It's gonna be C2, ganon. Okay, C2, ganon, like that, H2, ganon, o diba? Ganon. So, C2H4, ganon. Okay, C2H4. Okay. What's the magic here? Wala ko na abot sa magic mo, inom sa kong coffee. Kinain magic nga may tabo. Di ba, yung ano mo yung science, dahil mo magic nga may tabo ba? Because scientists also have a very, very critical thinking. Sometimes they try to act more than our Almighty God, but they cannot do that. Okay? Because things like unexplained natural phenomenon, meaning natural phenomenon, sometimes cannot be explained through science. That's what I told you several times. Just like water. You add gas and a gas and then it produces liquid. It's impossible. But God created water as a liquid. But the raw materials are hydrogen gas and oxygen gas. Then why it became a liquid? So this phenomenon or scientific phenomenon cannot be explained by scientists. Okay, so meaning to say, this is a proof that our Almighty God is higher than them. But, sad to say, some scientists will act more than our God. Okay, that's why they prefer to choose a religion which is called atheist, meaning they don't believe in God. But actually not all, but some of them. Okay, not all ha. Okay. Okay. Disclaimer, not all, because some scientists also will bow down and kneel if there are scientific research they cannot explain well. They almost fail every time and they cannot solve. So that's why they bow down and offer prayers to the Lord, because they cannot succeed their scientific research or their observations on the phenomenon, whatever, or discovery, right? Scientific discovery. So things like this, okay? So mo na siya may tabo, guys. Okay, di ba? So the same also with acetylene. Inom sa kong coffee, why there's magic. Okay. Okay, ako rin na-discover, guys. I spent a lot of times in the library when I was in college. Okay, ako na itudlo. Okay. Now, C2H4 is, okay, this is ethylene. Ethylene. Gahi. Okay, gahi. So, asa naman ito ang one? Dili na siya acetylene. Okay? It's not acetylene. The ethylene, it's not the acetylene. But, in your formulation of acetylene, it will produce an ethylene. Why? Diba? Nakakaloka. So, there's a magic. Okay? So, let's try. So, meaning to say, this acetylene here that we use in our welding operations or whatever, something like that, the gas cylinder, right? Normally, it's acetylene. That is acetylene, E-N-E, that is belong to the double band actually. But if you use this formula, it will never be in that group. Why? So, let's try another group. Maybe it will be in the single band group or in that triple band group. In that situation, it already deviated the science phenomenon, right? And supposedly, this acetylene will be in the number 2 because of the word E-N-E, double bond. And now let's try the triple bond. Okay? The formula of the triple bond. Diba? Na siya milagro na hitabo. Okay. Okay. The scientists cannot explain this also. Okay? Like that. If I cannot explain, who am I to explain deeper for this? Okay? Like that. Okay, this acetylene. So you use triple bond, breaking the theory and concept. Okay, so CnH2n minus 2. This is not triple bond. Now, the triple bond is Y-N-E in the last 3 letters. Supposedly it will become acetylene. But it's not. It's acetylene E and it's in the double band. So in the first place, it cannot be justified. Okay, let's just follow the triple bond. Okay, and the same carbon atom 2. So C2H2 times 2 minus 2. So it's gonna be C2H4. So C2H2. This is the chemical formula of acetylene. C2H2. 2 atoms of carbon and 2 atoms of hydrogen. But this is in the triple bond. So supposedly, it should be acetylene, not acetylene. But why it doesn't meet? Okay? So meaning to say, you will always use this hydrocarbon formula just to satisfy what do you mean. Okay, not relying on the 3-letter words. Because sometimes also it will fail. Though most of the times it will be followed, but sometimes it will fail, just like acetylene. You get the point. Maybe there are also others that will deviate. If you, okay, so for example, so this is acetylene. This formula C2H2 is the acetylene. 2 atoms of carbon and 2 atoms of hydrogen, not the C2H4. 2 atoms carbon and 8 atoms of hydrogen, right? Okay. Ganun siya, or 4 atoms of hydrogen. C2H4 pala. Okay? So don't be confused with the C2H4 and the C2H2. The C2H2 is the chemical formula of acetylene, not the C2H4. Okay? Because C2H4 is acetylene. Y-N-E. Okay? Oh, acetylene. Okay? This is acetylene. Okay. Again, this C2H2 is supposed to be acetylene. Diba? Okay. And then C2H4 is acetylene. But the acetylene is C2H4, not C2H2. But why the actual formula of acetylene is C2H2? Diba? Things like this cannot be explained. Let's forget that one, okay? Ako na siya na-discovered po. Okay? In my entire study. Okay? Like that. So, tuna ang Ranay Milagro. Water and acetylene. Sa ganito sa water, because you add gas and a gas, it will produce normally with the same phase gas. But God created water liquid, not gas, as the product of hydrogen atoms plus oxygen atoms. Number 1. Number 2, acetylene. Okay? Because acetylene is really in the triple bond. But then the term, the words, it's in the double bond. So it's wrong. Actually, but there's a miracle also. Cannot be explained during, I don't know why the scientists do this. Okay? Like that. Any questions so far? So matuki gini mo guys kung masikip basa-basa. Okay, when you go to the library, read a lot, like that, and go to different references and sources of the books, you can compare, oh, like this. Okay, so, it's gonna be like that. So there's books also that present the discussion very simplified, and there's also another books very complicated, and there's also another theory that is not found in another book, and you will compile that one in your brain cells, something like that, okay? And take down notes in areas in which you don't know yet pa, ganon. Or you can memorize, if it is really easy to memorize by understanding it in the first place. Okay? Any questions ako mga palangga? Okay. Yung origin ako, ikatampo ninyo, science, academic information. Okay. Thank you so much for watching mga palangga. If you like this video, you can comment down below in the comment section. And you can subscribe my YT channel if you want also. And you can click the notification bell for some newest updates of I am a singer, your voice, your YouTube content creator. Bye-bye. God bless everybody mga palangga. Okay, ganon. But here, in my FB Live